Assalamu alaikum everyone. I'm Ashrafur Rahman Shubho from CC12 batch. So today we'll make a presentation on theory of computing course. So in theory of computing we learned about different kind of computation model. So let's just talk about abstract machine. What is abstract machine? It is a theoretical computational model that accepts any kind of let's just say input string or input, and after processing it provides some output. So we can talk about a simple abstract machine which is a finite automaton, a finite machine. So we can further get two kinds of finite machine: a deterministic finite automaton and non-deterministic finite automaton. Using this machine we can process simple kind of string or input. After processing we can provide get accept or reject output. So for example, we get a regular expression for our regular language, a certain kind of string that can accept our this finite automaton machine, which is a string that ends with 2 concatenated 1. So for example, we write 3 string that ends with concatenated 2 1. So for this kind of string process, we have our finite automaton machine, which is a non-deterministic finite automaton. Here at the starting point, starting state, it can accept a number of zeros and ones, but at the end there should be 2 concatenated 1 to be accepted for a string. So this machine can easily recognize if our string can be accepted or rejected. So after discussing this thing, we can say we can understand that finite automaton can easily process simple kind of string and provide our output, but it cannot produce it cannot process a complex kind of string like this kind of string. It is equal number of, let's just say, equal number of A's and equal number of A's concatenated with equal number of B's. Let's just say 100 A's concatenated with 100 B's. So this kind of string cannot be processed using our finite automaton machine, as because our finite automaton machine has finite state, and it doesn't has any memory element to memorize the previous output. So to overcome this restriction, we get grammar. What is grammar? A grammar is a kind of model that has some production rule to identify or process a certain kind of string. So we can express our grammar using 4 tuples. A grammar consists of 4 tuples. A non-terminal, we can say that it's a variable or a placeholder that can be further divided and replaced by any kind of constant or terminal. So second tuple is terminal. We can say that as constant, which is it cannot be further divided into another simple segment. Then we got P, which is a production rule. So based on this production rule, we can process our input string. And then finally we get our 4th tuple, which is starting symbol. So using this 4 tuple, we can easily process any kind of regular language. So let's just say an example language which is a to the power n and b to the power concatenated with b to the power n, where n is greater than 0. So to produce this to process this language string, we can make some example string. So equal number of A's concatenated with equal number of B's. This type of string we get for this language. So to get process this language, we got our production rule, which is 2 terminal concatenated with a non-terminal. also we get another rule, which is S would be replaced by a epsilon, which is a zero length string. So we can see that first we get our starting rules, which is S would be replaced by A S B, which is B, which A and B is our non-terminal, and in the middle we got our sorry, A and B are our terminal, and in the middle we got our non-terminal. So in second case we replace this non-terminal with the first production rule, A S B, and we have our old terminal, and finally we replace this non-terminal again with our second rule with our epsilon, and then finally we get our expected string, which is accepted by this grammar. So we can see that in our in a parsing tree. In that parsing tree, we can see that intermediate nodes are our non-terminals, and the leaf nodes are terminals. So after discussing this, we can conclude that the finite automaton can be used in simple kind of string recognition, like pattern matching or search, but it cannot process complex kind of string. So for that we get our context-free grammar, or grammar normally. To using this grammar we can process a complex kind of string. Mainly it uses in parsing, string parsing, like mainly in programming language. So here in this in this tree structure, our grammar can handle a complex kind of grammar can handle a complex string, and can easily recognize any kind of complex string based on our production rule. And that is our today's presentation. Thank you all.